All right, hi everyone. This is by request from Walter and Geary, who wanted me to work out this question from the test you just got back. Okay, this was number 3 on the multiple choice section, obviously. All right, for what value of k, if any, is this the case? So the first thing I'm going to do here is I'm going to rewrite the improper integral on the left-hand side as a limit. So this is the limit as b approaches positive infinity. The definite integral from 0 to b of kx e to the negative 2x dx. I'm going to evaluate this left-hand side. Walter, the fact that you pulled k through, that shouldn't change anything whatsoever. So just, it shouldn't change anything at all. So just kind of follow your work with this slight modification. All right, I'm going to first recognize that this integral, the indefinite integral, is going to require integration by parts. And I may go over here to the side and recognize that u equals kx, dv equals e to the negative 2x, du equals k, and then one more derivative brings me to 0. If I take successive integrals here, right, I get v equals that, and then one more, I'm going to get 1/4 e to the negative 2x. The point here is I recognize a tabular integration by parts, okay, rather than doing parts twice. Now what happens is that this left-hand side, or sorry, this limit here in terms of the indefinite integral, this becomes then the limit as b approaches positive infinity of, let's see, negative 1/2 times kx e to the negative 2x, because remember it's positive and then negative, right? Then minus k over 4 e to the negative 2x, okay? So just being really careful with all of our work. When it comes to multiple choice, we're just really, really careful because we know it's just all or nothing. Okay, then it becomes a matter of integrating this integral. And what you have to recognize here is that as b approaches positive infinity of this definite integral, when I integrate from 0 to b, what I'm going to do here is be very careful. Come on down with me here. Limit as b approaches positive infinity. I don't know if you can see this here, but now I'm going to actually factor out k over 2. Okay, and here's where Walter, this is what I mean, like in the end it all works out nicely. I'm going to factor that constant k over 2 out because that's not going to affect my limit at all. So now I have the limit as b approaches positive infinity of, okay, this becomes negative x e to the negative 2x minus 1/2 e to the negative 2x. Everyone all right? Evaluated from 0 to b. Okay, and this is going to equal k over 2. Now here's where I'm going to input in b and input in 0 for x. So it's going to get a little bit congested. So negative b times e to the negative 2b. And I just realized I lost my limit statement. Let's go over, as I just said, k over 2 times, all right, limit b approaches positive infinity of negative b e to the negative 2b minus 1/2 e to the negative 2b minus the quantity 0 minus 1/2. All right, so what I've done here, if you can see, oh, for some reason my k over 2 just got here, just kind of erased itself. So k over 2 times all of this, like times this whole thing here, right? Big parenthesis there. All right, so now let's take a look what's going on. As b approaches positive infinity, okay, this term here is going to approach 0 minus the quantity negative 1/2. All right. As b approaches positive infinity, and I think this is the second time I've seen this happen in our work with limits, whether it was improper or L'Hopital's rule. As b approaches positive infinity, look right here. This is interesting. As b approaches positive infinity, negative b approaches negative infinity times e to the negative infinity, which is 0. And this right here is an indeterminate form that requires us to work through. So let's walk down here and just kind of work through that. Let's go down here and just take care of this for a minute. The limit as b approaches positive infinity of negative b e to the negative 2b. You know it equals the indeterminate form of negative infinity times 0. Okay? You also know that indeterminate forms of this type, the first thing we do is try and rewrite the argument of the limit in a form that will yield a L'Hopitalable indeterminate form. So a little bit of algebra, I did this, and this brings me to here. Negative infinity over positive infinity. This is a nice L'Hopitalable indeterminate form. The limit as b approaches positive infinity, I'm using L'Hopital's, -1 all over 2e to the 2b. We clean up, nothing to clean here. As b approaches positive infinity, this all equals 0. So let's walk it way back, walk it all the way back, walk it all the way back. Now we know this entire expression will equal k over 2 times 0, so 0 minus -1/2, or just 1/2, all right? Now, what did we say this whole improper integral has to equal? 1, okay. So, if we know that k over 4 needs to equal 1, therefore, k equals positive 4. Look at that. Okay? I mean, there's a couple of arguments that you can make here, all right? The argument that one could make is, you know, how on earth could this just be a 2-point question? And I will tell you something here. You know, in my experience looking at multiple choice questions for an AP exam, this is a pretty long multiple choice question. This is a question that I did not take off of an old AP exam. I think I found it, I think I found it in just kind of my old paperwork way back in the day. But right now, the reason why I put it on the test is because it's a great question that makes you deal with a whole host of topics in one question. Improper integral, integration by parts, indeterminate forms, right? And threaded throughout this question is an attention to detail that is required as well. Okay, so Walter Geary, I hope that answered your question, and anyone else who may have watched the screencast, I hope that helped as well. Goodbye.